Hello all, this video is for the students of class 12th. This video contains solutions of Physics Class 12th NCERT exercise questions 1.1 and 1.2. Let us start with the first question, that is question 1.1. What is the force between two small charged spheres having charges of 2 into 10 to the power of minus 7 coulomb and 3 into 10 to the power of minus 7 coulomb placed 30 centimeter apart in air? Let us solve the first question. Suppose this is a sphere with a charge q1 and this is another sphere with a charge q2, and let the distance between these two spheres be r. So in the question they have given the charge of the first sphere is 2 into 10 to the power of minus 7 coulomb and the charge of the second sphere is 3 into 10 to the power of minus 7 coulomb, and the distance between these charged spheres is 30 centimeter. What you have to find out here? The force. So there are two types of force. One is repulsive, another one is attractive. Attractive force and repulsive force. Repulsive force means when two like charges comes closer, these charges will repel each other. Similarly, when negative and negative come closer, it will repel each other. This force is called as repulsive force. Attractive force means when a positive charge comes closer with a negative charge, these charges will attract each other. This is called as attractive force. So here we are having two positive charges. Q1 and Q2 both are positive. Therefore, the force here is repulsive. Now, what is the formula for finding force? It is by Coulomb's law. By Coulomb's law, the force between two charges, force between two charges is 1 by 4 pi epsilon 0 into q1 q2 upon r square. This is the formula. We have used epsilon here, epsilon, because in the question they have given these charges are placed 30 centimeter apart in air. It is placed apart in air. If it is air or vacuum, we use epsilon 0. If it is air or vacuum, if it is mentioned in the question air or vacuum, we use epsilon 0. So this is our formula, 1 by 4 pi epsilon 0 into q1 q2 by r square. Now you have to remember 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power of 9. What is q1? q1 is given in the question, that is the first charge. Value of the first charge is 2 into 10 to the power of minus 7 coulomb. So q1 is 2 into 10 to the power of minus 7 coulomb, and q2 is, what is the value of q2? 3 into 10 to the power of minus 7 coulomb. What is r? r is the distance between these two charges, distance between q1 and q2. It is 30 centimeter. R is 30 centimeter. Now you have to substitute all these values in the formula. Before that, you have to remember R is always taken in meter. Here R is given in centimeter. R is given in centimeter, but you have to always use R in meter. Okay, so you have to convert 30 by 100, which is equal to 3 by 10 meter. We can use this in the equation. So let me substitute all the values here first. F is equal to 1 by 4 pi epsilon 0 is 9 into 10 to the power of 9 into 2 into 10 to the power of minus 7, which is Q1. Next Q2. Q2 is 3 into 10 to the power of minus 7 upon 3 by 10 the whole square, because R square. This is R. 3 by 10 meter is R. So 3 by 10 the whole square. Now we have to solve this. What is 9 into 2? 18. 18 into 3? 54. 54 into what is 10 to the power of minus 7 and 10 to the power of minus 7? It is 10 to the power of minus 14 into this one 10 to the power of 9, that we can write it as 54 into 10 to the power of minus, what is minus 14 and 9 plus 9? It is 10 to the power of minus 5. 54 into 10 to the power of minus 5, and in the denominator you have this 3 by 10 square. 3 by 10, 3 square means 9, 10 square. This 10 square you can bring to the numerator, so that it will become 54 into 10 to the power of minus 5 into 10 to the power of 2, and in the denominator you have 3 square, which is 9. Now you can cancel this. 9 into 6 is 54. Now you can reduce this into 6 into 10 to the power of minus 3. So this is the force. Force is equal to 6 into 10 to the power of minus 3. You have to write the unit Newton. So this is the force between the two charges Q1 and Q2. Let us move on to the next question, that is question 1.2. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the two spheres? What is the force on the second sphere due to the first? Let us solve this question. In the question they have given the force between the two charges, that is force is equal to 0.2 Newton. This is one sphere Q1, this is another sphere Q2. So in the question they have given the charges of these spheres. The first sphere is 0.4 microcoulomb and the charge of the second sphere is minus 0.8 microcoulomb. So in the first part of the question you have to find the distance between the charges. So R is equal to how much you have to find out. So an important thing that you have to notice here is they have given the charge in microcoulombs. So you have to convert that to coulomb. So 1 microcoulomb is equal to 10 to the power of minus 6 coulomb. Therefore 0.4 microcoulomb is equal to 0.4 into 10 to the power of minus 6 coulomb. Similarly, minus 0.8 microcoulomb is equal to, you cannot use a negative sign or any sign while finding force. When you substitute the values of Q1 and Q2 in the formula for force, never take the sign. So what you will write here, you have to write only 0.8 microcoulomb. Don't use the sign. So 0.8 microcoulomb is equal to, when you convert that to coulomb, 0.8 into 10 to the power of minus 6 coulomb. Now you have to substitute this in the equation for Coulomb's law. That is, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 upon R square. 1 by 4 pi epsilon 0 is 9 into 10 to the power of 9. Q1 is given in the question. It is 0.4 into 10 to the power of minus 6 coulomb. This one what we have converted. Q2 is equal to this one, 0.8 microcoulomb, which is equal to 0.8 into 10 to the power of minus 6 coulomb, and force is given, F is equal to 0.2 Newton. Now you have to substitute this in the equation. F is equal to 0.2 into 9 into 10 to the power of 9, that is 1 by 4 pi epsilon 0 is 9 into 10 to the power of 9 into Q1 is 0.4 into 10 to the power of minus 6. Q2 is 0.8 into 10 to the power of minus 6 upon R square. Now we have to find R. Therefore, R square is equal to 9 into, you can solve this, 10 to the power of minus 6 into 10 to the power of minus 6 is 10 to the power of minus 12 into 10 to the power of 9 is 10 to the power of minus 3 into 0.4 into 0.8 upon 0.2. Now you can cancel the 0.2 into 2, which is equal to 9 into 10 to the power of minus 3 into 2 into 0.8 is 1.6. Now if I multiply and divide this equation with 10, multiply and divide this equation with 10, it doesn't make any difference. So I can change this as, I can rewrite this as 10 to the power of minus 3 into 1.6 into 10, that is 16, into 10 to the power of minus 1, that is, I can bring this in the numerator, 10 to the numerator, so that I can write it as 10 to the power of minus 1. This is equal to 9 into 16 into 10 to the power of minus 4. This is your R square. This is your R square. What you have to find? You have to find R. Therefore, I can write this as 9 into root of 9 into 16 into 10 to the power of minus 4. Now remove this root. Before removing this root, I can write this as 9 as 3 square, 16 as 4 square, and 10 to the power of minus 4 as 10 to the power of minus 2 the whole square. Now we can remove this root so that you can write it as 3 into 4 into 10 to the power of minus 2, which is equal to 12 into 10 to the power of minus 2, which is 0.12. This is in meter. R is equal to 0.12 meter. So you have to change that to centimeter. For changing that to centimeter, 0.12 into 100, which is equal to 12 centimeter. So this is the answer. This is the distance. 12 centimeter is the distance between these two charges. 12. This is the distance between the charges Q1 and Q2. Let us solve the second part of this question. What is the force on the second sphere due to the first sphere. This is the question. So what is the nature of force? What is the nature of the force? What is the nature of force? It can be repulsive force. It can be repulsive force or attractive force. What is repulsive force? When two charges, maybe positive charges, two positive charges comes closer, it will repel each other. Or when two negative charges comes closer, it repels each other. This is called as repulsive force. Whereas in attractive force, when two charges, maybe one positive charge and negative charge comes closer, it is going to attract. Positive charge and negative charge will attract, and that force is called as attractive force. So in this question, there are two charges. One charge is 0.4 microcoulomb and the other charge is minus 0.8 microcoulomb. So one is having positive charge, another one is having negative charge. So they are going to attract. So here the force is attractive force. Whether minus 8 microcoulomb charge is attracting 0.4 microcoulomb with 0.2 Newton force towards it, or if 0.4 microcoulomb attracts minus 0.8 microcoulomb charge towards it, the force is the same. Force is how much? Force is 0.2 Newton. Whether this 0.4 is attracting 0.8, this arrow mark should be towards this. Whether the 0.4 is attracting minus 0.8 or minus 0.8 is attracting 0.4 towards it, the force applied is the same. Force has only one formula. So here it is having attractive force between these two charges, and the force is going to be the same. So the answer for this is, what is the force on the second sphere due to the first? It is the same. It is 2 Newton. The solutions of the remaining questions will be included in the next video. If you have any suggestions or doubts, please comment on the comment box. Thanks for your time.